All right, in today's fun and exciting episode of Math with Marty, what we're going to be talking about is momentum. In fact, we're going to be talking about conservation of momentum. Okay, now what was momentum? Momentum was in our last video where we kind of briefly talked about impulse. So momentum is P equals m times v, where we say that the momentum vector P, this is momentum, is directly proportional to mass. So if mass gets bigger, then so does momentum, and if velocity gets bigger, so does momentum. Okay, that's how it depends on each quantity. Now, what does conservation imply? Conservation implies that momentum, so this is the conservation aspect of today's lesson. Conservation, okay? Momentum before a collision equals momentum after a collision. So let's say you have a system, okay? And in this system, you have two objects that are colliding. Okay, so let's say we've got two balls, A that is traveling at some velocity v that collides with a ball B, okay? And B is, so let's say VB, so the velocity of B is 0. It is at rest. And the velocity of A is some value, I don't know, it could be 10, 20 meters per second, could be something, whatever it is. And then, so this is before collision. And then after collision, ball B is going to move a certain amount due to the fact that it's gained some velocity due to the impact from A. So ball A is going to make an impact with ball B, and ball B is going to move, okay, forward at some new velocity VB. Okay, this time it's not 0, all right? And ball A is also going to move at a new velocity. And to demonstrate the new velocity, what I'll do is I'll just put a prime, okay? Demonstrate the new velocity for VA, I'm going to demonstrate a prime as well. And it's going to move at some other velocity VA. So what this is telling us, and by the way, ball A has mass A and ball B has mass B. Conservation of momentum, what that means is that the momentum, the total momentum before equals the total momentum after. So MA times VA plus MB times VB equals to MA VA prime plus MBVB prime. This, folks, is the conservation of momentum, because momentum before a collision equals momentum after. Now, the only way that this is true, so only true, this is only true for ideal systems. Now, what's an ideal system? An ideal system is a system with negligible friction, okay, where friction is assumed to be absent from the situation, okay? So it is an ideal system, which isn't realistic, but it is ideal for a reason, and it simplifies the situation for us, and we can do a lot of reasonable calculations using this conservation momentum scheme. So like, for example, I've got a ball. Okay, this is an example. I've got a ball moving forward at 2 meters per second. Its mass is 5 kilograms. It encounters a ball B at rest, but ball B is 2 kilograms, and ball B's velocity is 0, so it's at rest. And then after the collision, ball A is now moving at some speed that I need to figure out. Ball A's mass is still 5 kilograms, and ball B is moving at, let's say, 1 meter per second at 2 kilograms. So now, using conservation of momentum, can I determine what VA's velocity is after the collision? And the answer is yes. So I've got all the quantities I need. All I have to do is set up my equation. So MA VA plus MB VB equals MA VA prime plus MB VB prime. All I have to do is plug in all my quantities. Now VB before the collision is 0. So this is gone. Okay, that's 0. MAVA is 5 times 2. Okay, 5 kilograms times 2 meters per second. And VB's new velocity, let's just write MA here, VB's velocity after the collision is 1 meter per second. So all I have to do, I forgot these units here, all I have to do is isolate for VA. Okay, so if I run through this calculation, what I'll find is that I've got 10 plus, let me just show you how I got that. So 10 is 5 times 2. So 10, not plus actually, 10 minus, and I'm going to move that over to the other side. 10 minus 2 equals 5 times VA prime. Because of that, 5 times VA prime. And then 10 minus 2 is 8. And that's in kilograms meters per second. Times 5 kilograms VA prime. All I have to do is divide both sides by 5 kilograms. And I will get the speed, or the velocity, after the actual collision for VA. And that quantity is simply 8 over 5 meters per second. VA prime, because that cancels. Okay, so that is an example of how we can use the conservation of momentum to solve for quantities in physics examples, in physics problems. Okay, so let's just go through it one more time. So how we started this lesson is we talked about momentum. We talked about what conservation meant. Conservation is momentum before a collision equals momentum after a collision. We showed an example where you have two balls, A and B. One's at rest before the collision. After the collision, A makes contact with B and sends it flying. We set up the equation for the collision, and I used primes to demonstrate like after the collision versus before. So this is after, okay, and this thing is before. And what I had to state is that this is only true for ideal systems, which means that there is no friction assumed in this system, okay? And then I gave you a specific example where VA is 2 meters per second, MA's mass is 5 kilograms, VBs is 0 at rest, and that mass is 2 kilograms, that's before. So this thing is before collision, and then this thing is after, and I was trying to find A's velocity after the collision. So I set up the equation isolated for A's velocity. So I'd say the velocity of A is 8/5 meters per second forward. And then I'm going to add after the collision. Okay, so that is an example of how to use conservation of momentum. I hope this video was informative. I know it's a lot to take in at first, but if you did enjoy it and you want to see more content, leave a like, subscribe, comment, and I'll see you in the next one. I love you guys. Peace out. Bye-bye.